Thanks everyone for joining us today. My name is Jake. I'm with Leeds Forensic Systems. We're doing another one of our Leeds Helpful Tips live streams. Today I've got Ashley on the camera, so Ashley's going to be helping me out. And yeah, today should be a pretty good, quick, but I think hopefully helpful and interesting live stream for everybody. So the system I have behind me is one of our Leeds spectral vision systems. These systems are most often used in biological screening, so looking for biological fluids like blood stains, semen stains, saliva stains, pretty much any biological stain. The system is an ALS system, so you can use it to screen with. But what's really cool is we've actually ended up having a lot of labs either in the bioscreening side that have a firearm section, or even some firearm sections themselves be able to purchase the system for screening gunshot residue. So that's what today's quick tip is all about, is using the LSV2 system to screen and document gunshot residue without having to do a Grice test. I think maybe sodium rhodizonate test. I think I got that right, not too sure. But the idea is you can just image it, that type of thing. Before we jump in any further, this is a live stream, so it's coming to you live from our offices in Minneapolis, Minnesota. But what that does mean is sometimes things can happen. So if anything happens, like our feed drops or a stumble or anything like that, please bear with us while we try to bring things back. It's also hosted through YouTube, which is kind of cool. And that means we have a little chat window on the right-hand side. So if you have any questions while I'm giving this talk, or you would like to bring feedback or comments, you're comfortable with it, you can log in and just drop a comment. And every once in a while, I'll check over and see if there's any questions. So, all right, I don't see anything so far. So yeah, we'll go ahead and dive in. Quick note before we begin actually using my samples, I do have some gunshot residue samples. My gunshot residue samples are probably a little bit different than your gunshot residue samples, with the fact is there's not a lot of blood on them. So you will probably see a lot more blood stains on your gunshot residue and have a lot less clean samples than I have. So yeah, let's dive into it. Our first sample that we have today is a kind of a plaid shirt. So you can see it right here. I like this as an example for the gunshot that we're looking for because it's got a lot of extra pattern going on, which can be kind of hard to just visually look at and see. So the LSV2 system is an ALS imaging system that ranges from the ultraviolet into the infrared, the near infrared. And what that means is for biological screeners, the idea is that they can change light and change filter to try to bring the contrast out of the semen stain or the biological stain they're screening. For firearm examiners that are interested in doing a quick screen for gunshot residue, trying to find places they want to document, there's really kind of two filter and light combinations that I've heard that work the best and seem to work the best. The first one is using the near-infrared light with the near-infrared filter. So we're just looking in the near-infrared spectrum because the gunshot residue will absorb those infrared wavelengths, where the fabric will reflect back those infrared wavelengths. Probably I would assume lead would be absorbing a lot in there. And then we also have our fluorescent filter and light combination, specifically our blue wavelength of light at 455 nanometers with our red filter, which is at 610 nanometers. First example I'm going to give you, though, is with the infrared setting. And what's kind of cool is infrared visualization of gunshot residue has been around for a long time. It's actually been used with old school infrared photography. But with digital cameras now, it's faster and a lot easier to work with. So first thing I'm going to do is, here's my head, here's my software. Let's see if we can get a zoom in here. Yep. What I'm going to do is I'm going to change from my white light setting to my infrared setting. The LSV has presets loaded over here. Those are customizable. So if you want to make a custom preset for gunshot residue that you can just click on and go to, you can certainly make one. But what I'm going to do for this helpful tip is just manually pick filters and lights. So I'm going to go ahead and start with my light. We're going to change it from our white light. We're going to switch it to our infrared. I'm going to choose that. And now what I'm going to do is I'm going to go over to my filter and change it from my clear filter to my infrared filter. which is at 830 nanometers. I'm going to choose that. And very quickly, you can see how the background has just gone. So what's happening here is I'm shining infrared light at the sample. The fabric is reflecting back the infrared light. And the hope here is that what we're going to see is we're going to see if there's any gunshot residue on this shirt that is going to be absorbing that infrared light. Being knowledgeable about the sample, I can guarantee you there is. So we're going to go ahead and search around. And there's this particular defect that's interesting here. And what's kind of neat about it is I'm going to go ahead and just bring these closer together. Going to kind of lay it out. Something I always recommend doing, as long as your sample is not crunchy, and even if it is, try to lay it out as flat as possible. So we're going to lay it like that. I'm going to go ahead and zoom in. And again, I have this parfocal zoom control, so I can zoom in. And when I focus, and then I zoom out, the image is going to stay in focus. And what's kind of neat about this particular area that we're looking at here is you can see that there's this pattern. And so what this is from a shotgun wad. So it's a shotgun wad slap. So when the shotgun is shot, the wad comes out, it's got all the pellets packed into it. It opens up, and it's got a limited travel range that it will fly before it drops to the ground. And so what this is the actual wad, the pellets have all gone through the shirt. Here, the wad has slapped the fabric, leaving behind this kind of like a flower-looking pattern. And that's kind of interesting. So what I can do with this is I can go ahead and just hit my capture button. I take a picture, and then very quickly I can just switch over to my white wavelength of light and my clear filter and wait for the camera auto exposure to catch up, and then I can capture over the exact same area just with different settings. And so what's nice about this is, just like for the biological screeners where you can do a side-by-side comparison of all your blood stains on your black shirt and then the infrared or the white light, we can do the same for gunshot residue. So I can come in, I have this capture here, I have my white light picture, and then I can just very quickly go to Tools, Compare to, Capture For, and I can actually get them side by side. What's kind of neat is this is just a picture, there's no measurement data, but what's neat about the LSV is if I had a scale someplace in the window, what I can do is I can teach the system how many pixels are in that, how many pixels equal that inch in the scale, and then the image is calibrated. So then I can actually do calibrated measurement. So let's just say let's say there was a scale here, and I knew that this was, I'm just going to call it, make up a measurement. Probably should have thought ahead and actually had a scale here, but let's just say that that was 1 inch. Now this image is permanently calibrated. So then I can come in and use these measurement tools, and like circles, I can actually measure individual lines. So if you want to get pattern and spread and have it calibrated and measure that way, that's something that you can certainly do. So yeah, let's go back to this. So that was just one example of a patterned shirt. The LSV can also be used, this infrared gunshot residue can also be used on a lot of dark fabrics. So it works really well on like black cotton, things like that. You can really get that gunshot residue to pop out in the infrared. So we're going to go ahead and transition over to a slightly different shirt. Something else you'll notice is that I'm working fairly close to my sample, but the LSV also has the ability to move the head far back, and you can actually capture whole overviews. So if you want to get the head very far away and capture that large overview, that's certainly something you can do. And the cool thing is, when you're working in the infrared spectrum, the system is very sensitive to infrared light. And so you're going to still have good detection even at very long range. I'm not going to go through that right now. What I'm going to go through next is just a little bit about another infrared example, kind of close up so it's bigger so you guys can see it easier. And then I'll show you a fluorescence example. So here's our example, our shirt again, dark shirt. We can very quickly switch over to our infrared light with our infrared filter. And again, this time it's a black shirt, but we're really being able to pick out a lot of details from some bullet wipe up here, and then another, what looks like another shotgun another shotgun wad slab down here. And what's cool with this one is you can also see that stippling. And not a firearm examiner, but I will defer to everybody else, but this almost looks like vaporous lead. But again, you'd want to do a chemical test on any of this to determine what it is you're actually looking at. So again, I can take a picture, that type of thing, and move on. One last thing I was going to show you guys is fluorescence. We're going to see if this is going to work. So actually, if you want to zoom out real quick. So a quick note on fluorescence. The LSV infrared light is reflected light. We're not causing anything to fluoresce. We're just shining infrared light down at the sample. Sample reflects back the infrared light. The gunshot residue absorbs it. So it's reflective light imaging. It's like you're shining a flashlight at something and light's bouncing back. So we don't have a lot of sensitivity issues at range. Fluorescence, though, totally different story. Because what we're trying to do is cause the gunshot residues themselves, so maybe it's the nitrates or nitrites, not quite too sure, but something in the gunshot residue is fluorescing, and we're trying to hit it with an excitation source that causes it to emit light. So one of the biggest things, if you're ever going to be doing work in fluorescence, is to physically get the head closer, because then exponentially more light is hitting the sample. The intensity is exponentially greater, and exponentially more light then is it doesn't have to spread out as far as it comes up to the optics. So to do that, I'm going to just bring the head closer to the sample. So I'm going to bring it closer. I'm going to move my lights around a little bit. And now what we're going to do is to bring the head closer. You'll see it's totally out of focus. What I'm going to do is switch to a bigger diopter lens, or a bigger macro lens, if you will. And that lets us get closer and in focus. So I'm going to go ahead and use my +2. And just like last time, I'm going to use that parfocal zoom. So I'm going to go ahead and zoom in. I'm going to focus. This is actually a really cool example of the magnification you can get if you ever needed it. And now I'm going to go ahead and zoom out. And now I can try different light and filters. So this particular one, what we're going to do is we're going to use our blue light with our red filter at 610 nanometers. And you'll want to do this in a dark room because we're only wanting to detect fluorescence. So actually, if you could go hit the lights, and I'll turn off this ring light. It's not very easy to see, and this might not actually be the best sample for it, but you can see some very faint little specks of light in the fabric around the defect. When you're working with, and you could spend some time trying to optimize it, and this just might not be a good sample. But if you're working in fluorescence, what I recommend you do is increase your gain up. That makes the camera more sensitive to light. And let's decrease our brightness down a little bit. Let me bring it down a little bit more. But it's trying to balance these two, increasing the gain, playing with the brightness to try to get it so you can detect any pattern that's there. This may not actually be the best sample, but what's neat about this is blood will also show up in the infrared spectrum, whereas blood doesn't generally fluoresce. And so if you have a gunshot residue pattern or stippling and you've got microspatter of blood, you can try to use fluorescent, see if you can get the gunshot residue to fluoresce because the blood won't. And that can help you try to find a pattern that's separate from the blood stains, if that makes sense. So recommend trying it out. Again, it's just the blue light with the red filter. I recommend bringing the head close to the sample and then boosting up the gain. Another thing you can do, and you won't be able to see it in this dark room, I'll just do it, but you can also, if you're having difficulty, like we're having some difficulty seeing or getting enough energy, you can actually bring the lights closer to the sample. And when you bring the lights closer, you can see now how we're getting a little bit better detection. You again, even an inch exponentially increases the amount of energy is hitting the square area. So hopefully try it out. And if you get stuck, you can absolutely call me. Okay, so hopefully that was a good, kind of quick, helpful tip just to even try it out. We have quite a few LSV systems in the United States and in Canada. And if you have a DNA section and you're a firearm examiner and they'll let you in, it could be something that's kind of helpful to experiment with if you're trying to just very quickly screen for gunshot residue, document for gunshot residue, and then move on with your day. and see if we have any questions in the chat. I don't. So yeah, that's all I got for today. Thanks for watching. If you have any suggestions on future videos or things that you want us to train on or talk more about, please feel free to email me at jkurth@leedsmicro.com. And until next time, thanks for watching.